Yo, what's up everybody? It's your boy Paramba Trading, and we're diving deep into something truly next level today, quantum computing. We're not talking about your dad's computer with a fancy name slapped on it. This is the kind of tech that makes your current rig look like an abacus. Imagine trying to brute force a password on your laptop. It'd take forever, right? Now picture a quantum computer just strolling up and cracking the code like it's nothing. That's the kind of power we're talking about. Get ready to explore how this mind-bending tech is going to reshape everything from how we secure our data to how AI learns. We're talking breaking encryption, turbocharging AI, maybe even curing diseases. Let's get into it. Alright, so before we jump into the crazy applications, we gotta understand the basics. Classical computers, the ones we use every day, they use bits. Think of them like a light switch. It's either on 1 or off 0. Simple, right? Quantum computers, they use qubits. And this is where things get wild. Qubits can be a 1, a 0, or both at the same time. Yeah, you heard that right. It's called superposition. And it's like the qubit is living a double life. Think of it like this. Your regular computer is flipping a light switch on and off. A quantum computer is controlling the sun itself. It can be bright, dim, or anywhere in between. That's a whole lot more power and flexibility. But wait, there's more. Qubits can also be linked together through something called entanglement. This is where things get seriously freaky. Imagine two qubits, miles apart, acting like they have some kind of telepathic connection. Change one and the other changes instantly. It's like magic, but it's real science. Now, I know this sounds crazy complicated, but trust me, the applications are where things get really interesting. We're talking about solving problems that would take classical computers longer than the universe has existed, and that's just the beginning. So we've got these superpowered qubits, but how do we actually use them? That's where quantum algorithms come in. These are like the software that tells the quantum computer what to do. One of the most famous ones is Shor's algorithm. This bad boy can factor large numbers exponentially faster than any classical algorithm. Sounds boring, right? Wrong. Factoring large numbers is the backbone of modern encryption. Think about it. Your online banking, your private messages, even top-secret government files, they all rely on encryption that would take classical computers billions of years to crack. Shor's algorithm could potentially do it in hours or even minutes. Yeah, it's kind of a big deal, but it's not all about breaking the internet. There's also Grover's algorithm, which is like Google search on steroids. It can search through massive databases exponentially faster than any classical algorithm. Imagine finding the exact information you need in seconds, no matter how much data there is. These algorithms are just the tip of the iceberg. As quantum computers get more powerful, we're going to see even more incredible algorithms that will revolutionize everything from drug discovery to material science. Okay, so we've established that quantum computers could potentially break the internet as we know it. But don't freak out just yet. The same tech that could break encryption can also be used to create unbreakable codes. Enter quantum cryptography. Remember that whole entanglement thing we talked about? Turns out, it's perfect for creating secret keys that are impossible to intercept. Imagine you and your friend each have a pair of entangled particles. You use them to generate a random string of zeros and ones, which becomes your secret key. Since the particles are entangled, any attempt to eavesdrop would instantly change their state, alerting you to the breach. This is called quantum key distribution, or QKD. And it's like having a direct line to your friend that's physically impossible to tap into. It's the ultimate defense against quantum hackers. Of course, this is just the beginning of the quantum cryptography arms race. As quantum computers get more powerful, we're going to see even more sophisticated encryption methods that will make today's security look like child's play. Alright, let's talk about everyone's favorite buzzword. Artificial intelligence. AI is already changing the world, but quantum computing is about to kick it into overdrive. Imagine training AI models in minutes instead of months. That's the kind of speed boost we're talking about with quantum machine learning. Quantum computers can analyze massive data sets and identify patterns that would take classical computers years to find. This means we can develop more accurate and powerful AI models for everything from weather prediction to drug discovery. Imagine a world where doctors can use AI to design personalized treatments for diseases like cancer, or where self-driving cars can navigate complex environments with human-like intuition. That's the promise of quantum machine learning. And hey, maybe we'll even get some hilarious quantum-generated memes out of it. who knows what the future holds? By now, you're probably thinking, this all sounds amazing, but I need a supercomputer and a PhD to even touch this stuff, right? Wrong. Believe it or not, you can start experimenting with quantum computing right now, from your own home. Platforms like IBM's Qiskit, Google's Cirq, and Microsoft's QDK let you write quantum algorithms and run them on real quantum computers in the cloud. Yeah, you heard that right. You don't need to build a multi-million-dollar lab to get your hands dirty with this tech. There are tons of online resources, tutorials, and communities that can help you get started. And the best part? This field is still in its infancy. That means there's a massive opportunity for anyone with the curiosity and drive to learn to make a real impact. Alright, enough talk. Let's see some quantum action. In this segment, I'm going to walk you through building a simple quantum coin flip using Qiskit. Don't worry, it's a lot easier than it sounds. First, we're going to create a quantum circuit with a single qubit. Think of this as our coin. Then we'll apply a special quantum gate called a Hadamard gate. This puts our qubit into a superposition, meaning it's both heads and tails at the same time. Next, we'll measure the qubit, which forces it to collapse into either a 0, heads, or a 1, tails. And that's it. We've just created a truly random coin flip using the power of quantum mechanics. Now I know this is a simple example, but it illustrates the basic principles of quantum computing, and trust me, once you start digging deeper, you'll discover a whole new world of possibilities. So, there you have it. Quantum computing isn't some far-off sci-fi fantasy, it's happening right now, and it's going to change everything. From breaking encryption to turbocharging AI, the possibilities are literally endless. It's up to us to decide how we're going to use this incredible technology to shape the future. So, what do you think? Are you excited about the quantum revolution? Let me know in the comments down below. And don't forget to smash that subscribe button and hit the bell icon so you don't miss out on more mind-blowing content like this. Peace out.